Today we're starting our series on stateful processing in Kafka Streams. Stateful processing can be a very complex issue because it requires us to manage a state where we store the data and so on. But thanks to some of the Kafka Streams abstractions, it can be very easy to work with state when we're working with Kafka Streams. Welcome to Programming with Matthew. So, why stateful processing? In our previous series, we saw how we can do stateless processing in Kafka Streams. This is very useful, but it's incomplete in relation to data handling. When we're handling data, we sometimes need more than what an event can give us. We need to relate the events with each other, and that's why we need stateful processing. We have to keep some sort of memory of what happened before so that we can know why is happening what is happening now. So, why do we want it? Because we want to perform aggregations. We want to know how the aggregate of all the events looks. We want to understand the relationship within the events. We want to know why this event preceded the other. And we also want to enrich our data with joins. We want to be able to join multiple streams with the stateful data that we already have, so that we can present more insights in our data. In our applications, the state is stored in something called the state stores. Very creative, right? And these have the following characteristics. First, they are embedded into the application, meaning the store is contained in the same container in which the application runs. Also, you can configure it to run in memory or in disk. If you choose to use it in memory, then it will be faster to process. But in cases of failure, where you have to reload the previous state, then it will have to reload the status from Kafka. And that would take much more time than if it was stored in the disk. So usually using the disk is the best approach in these cases. Also, you can query these state stores. You can read them, and you can implement REST APIs to access them and so on. Also, they are fault tolerant, meaning that the data is not only stored in the state store, but it's also stored in a special topic in Kafka. So if the data is lost for some reason, the Kafka Streams application will load the data from the special topic in Kafka. And the last is that it's key value based. So it fits very well with Kafka's overall design. So far we have been working with K-streams, but now we have to introduce a new abstraction called the K-table. K-tables are used to store the state of our application. They're basically key value stores in which we can store anything that we want, really. The only care that we have to have in these situations is that anything with the same key, any update that we do with the same key, is going to override previous states. So we have to be very careful and very sure of what we are storing. Table stream duality is a concept in which we can see that tables can be represented as streams, and streams can also be represented as tables. So they're basically two sides of the same coin. Tables can be represented as streams of changes, right? So every time there is a change in a table, we can stream that change. Also, a stream can be used to reconstruct the table. So if we have a stream of events, we can apply insert or update operations on the same key, and we will end up with the same table that we originally had. Okay, let's introduce our tutorial. In our tutorial, we're going to build a bank account system. Basically, our system is going to receive bank transactions from a stream, and we're going to update the balance in our clients. So we have the bank account transaction. As we can see, the transaction has an amount, it has an ID. Then we also have the bank balance. The bank balance has also an ID, it has an amount, and it also has the last time it was updated. It has the latest transaction, and we are keeping the latest transaction because we're going to need it when we want to stream rejected transactions. So the idea of the application is to create a topology in which we receive the bank transactions, we group them by the key is the account ID, and we are going to aggregate these transactions, and we're storing it into a bank balance. Once we store it, we want to stream it into a topic called bank balances, and then we also want to stream into a different topic the rejected transactions. So that's why we're filtering the rejected transactions here, and we're going to put it in the topic rejected transactions. Now we're going to jump right into the code so that we can start working with stateful processing. But before we do that, let me remind you to subscribe to the channel, like the video, and share it with your friends. It's very important and it's very helpful for me. Thank you. Alright, so we are in the code now. To follow this tutorial, just clone this GitHub repository, and don't worry because the link will be in the description. And also check out this branch called tutorial start. You can do that running this command here. And in here you will find a project which is already mostly set up. I didn't want to do a full setup of this project because we have been doing a lot of projects now, and I guess you are familiar with the project setup as. So let's browse the source code of the project. So we already have the dependencies in Maven. We also have the entry point for our application in the bank balance app. We can see that we have a configuration in the class stream configuration, and we have our topology in the bank balance topology. Then we create the Kafka Streams application and we start it. So the class that we have to implement, or the method properly we have to implement, is the build topology method. In here we can see that it's mostly empty, so we have to build the topology. Also, we will find a unit test, actually 2 unit tests, in which we run 2 scenarios. We have one scenario in which we read 3 transactions that are credit to the accounts, and we have one scenario in which we have a rejection of a transaction. So in this case, the transaction is actually rejected. Let's zoom out a little bit. We see here what we are trying to do is we are sending a bunch of transactions into the bank transaction topic. So we have 3 transactions, and if you notice, the first one is a negative transaction, so it's a debit. But since it's the first transaction for this account, it means the account is going to be debit when it doesn't have the funds, so the transaction has to be rejected. So what we do at the end of the test is we verify that this transaction was actually rejected. As we can see here, transaction 1 was rejected. And also we want to verify that the balances haven't been affected by the rejected transaction. So the first balance is in 0 because the transaction was rejected, it wasn't executed. So that's why we have this test. So if we run this test, they have to fail because, as we saw earlier, the topology was empty. Yes, the tests have failed. Yep, because everything is wrong. The topology is not there, so we have to implement it. So let's start building our topology. First thing we're going to do is we're going to stream the messages from the bank transactions topic. So stream bank transactions, and we're going to consume them with, and we have to use the service long, service long, because the key of our topic is the bank balance ID. And we are going to use the serde for the value is going to be a JSON serde. So we're going to use new JSON serde bank balance. No, not sorry, not bank balance, bank transaction. There we go. So let's store this in a variable and let's use it right here. And if you don't know what a serde is, I recommend you to look at the stateless processing tutorials, because in those I explain what a serde is. But long story short, serdes are used to serialize and deserialize messages in Kafka. So we are going to group by key because we want all the messages that have the same balance ID grouped so that we can aggregate them. Once we have them grouped, we want to aggregate. And here we have a function that takes 3 parameters. The first one is an initializer. The initializer in our case is going to be a freshly created bank balance. So we want to create a new bank balance there. And just in case you don't know this notation, this is the method reference notation. It means we're going to use the default constructor for this class. The second parameter is the aggregator function. The aggregator function takes 3 parameters. We have the key, the value, and the aggregate. The key we know is the balance ID, the value is a bank transaction, and the aggregate is a bank balance. So we're going to keep everything aggregated in the bank balance. So we have to say aggregate, which is our bank balance, and we're going to say process. And we are going to process the transaction, so it's the value. And in here we have a method that we have to implement. It hasn't been implemented yet, so you see, we will be implementing this in our tutorial. But for now, let's leave it like this. The last parameter that we're going to send is materialize, which tells Kafka Streams how it has to construct the data store. So we're going to say materialize with, and we're going to send the serdes. So the serdes will be a long serdes for the key and a new JSON serde for the bank balance, because we want to keep them as JSON. So in here we say type bank balance dot class, and that's the type of our serde. And let's extract it because I feel that we are going to use it in a different occasion. Bank balance JSON serde. Okay, so this is going to tell Kafka to use these serdes to store the data in the disk. So now everything that we are aggregating is going to be stored in this state store. Now what we want to do is we want to stream this table, because we want to send updates about the bank balance. So we basically create a stream of bank balances. Let's say bank balance KStream. Now what do we do with this stream? So if we look in our topology, we will see, it's here, we will see that we want to stream it into the bank balances topic. So let's go here, bank balances 2, and the name of the topic is bank balances. And produce with, we're going to produce with, again, serdes long for the key, and then we have to use the bank balance JSON serde. Good thing that we stored it in a variable. And the last thing we have in our topology is that we want to inform of any rejected transactions. So if you remember, the bank transaction, the bank balance has a reference to the latest transaction, which we haven't really touched yet, but we have to store the latest transaction here. And why do we do that? We do that because we want to stream that into a different topic. So we are going to say bank balance KStream, and we want to map it first. So we're going to say map values, and we're going to say value dot get latest transaction. So now we have a stream of transactions, and with this stream of transactions we want to filter, and we want to keep only the transactions that are rejected. So it's going to be value dot get state dot equals, and we're going to say bank transaction state rejected. And finally, we're going to stream it to the rejected transactions topic. And we're going to produce with, again, long, in this case for the key, and bank transaction JSON server, because these are transactions. And we're basically done with our topology. So we should go ahead and test this, see what happens. Let's go back to our test. Let's run them. Whoops, still failing. Why? Oh, right. It's failing because we haven't implemented our process method. So now we have to process every bank transaction and update the bank balance. So this is what we're going to do now. Let's focus for a moment in the first scenario. The first scenario, we don't have negative transactions, which should be easier to implement. So let's take a look. It says we have 3 transactions. First one is for account 1, second one is for account 2, and third one is for account 1. So what we expect is we add these transactions into the topic. When we read the first balance, it should be account 1, and the balance should be 500. Then we read the second balance, and we get 3000 because it's 3000. And actually we should read the first balance. Let's add it right here because we missed it. Let's add, oh no, it's already there. So it's third balance, it's here, and the third balance is actually same account 1, but the value is 1000, so it got aggregated, and there is no rejected transactions. This is fine. So to implement this scenario, we would need to go into our bank balance class, and let's get the easy stuff first. So let's remove this comment, and we're going to say this.id. Okay, the ID should be the bank transaction get balance ID. Then we have the latest transaction. This one is easy as well. We can basically say bank transaction, and now we want to update the amount. So this dot amount should be the amount that originally was there. So this amount plus, so add bank transaction dot amount, get amount. So what will happen is that the amount from this transaction is going to be added to this amount. The amount from this transaction is going to be added to the aggregate amount. And as we can see, the amount is initialized in 0. So if we have 500 and we add it to 0, then we'll have 500. And then if we add another 500, then we will have 1,000, which is our test scenario. So if we go to our test and run it, it should pass. Let's take a look. Yes, it passed. This is great. And now we're going to implement the second scenario, which is a bit tricky because we have a negative amount. So in the cases in which the account doesn't have enough funds, we have to reject it. So if we go back to the balance, what we should do here is before we update this field, we should ask if this.amount add bank transaction amount compared to big decimal 0, it's greater or equal to 0. And here's what we're going to do. We're going to say this dot latest transaction dot set state going to be approved, and we are going to this dot amount, and we are going to finally add it. Add, actually this dot amount is equals to this amount add, and we are going to say this get amount. So this is fine. And so what happens if it's not, if the condition is not met? So if the condition is not met, what we have to do is reject the transaction. So latest transaction dot set state rejected. Finally, we forgot to update this dot last update, and we can say bank transaction dot get time, and we're done. So now we can run all the scenarios. If we go back to our test class, we run all the scenarios and let's see what happens. Awesome, everything passed. And yeah, now we're ready to go ahead and test this with a real Kafka. First thing we have to do is we'll have to run our Docker Compose. So as usual, our Docker Compose has Zookeeper and Kafka, and we have another image to create Kafka topics. So I also have configured the script to create the topics that we need. We need the bank transaction topic, the bank balances, and the rejected transactions topics. So let's go ahead and start our Docker containers. Okay, once the Docker containers are up, we can run our bank transaction producer. But before we do that, let's start a console consumer. So if we go to here, we can say create terminal, and we can go to our console consumer script and copy paste it here. Oops, value deserializer should be string deserializer. String deserializer. So it's fine. And now we can do this. Now if we run the producer, where is our producer? We can see the messages flowing through our application. And now we have to run the app. So let's go ahead and run it. And in our services, so we can see we have the account balances. We have the amount, so we can see how it's aggregating. We have ID 1, amount 500, and then it's 1,000. Then it's 500 because we decrease the as we see in the latest transaction, we have decreased it, and so on. So this is all working fine. We have some rejected as well. And so we can actually open another console consumer. Let's close this one. And let's open a different one. Here we have to say rejected transactions. So if we run this, and we see the transactions that were rejected for each account. And this is great. So everything is working. So this is all for today. I hope you have enjoyed this episode as much as I have enjoyed filming it. And I'll be waiting for you in the following episodes, in which we're going to dive even deeper into stateful processing, and we're going to see how we can query the state stores, how we can build REST APIs with the help of Spring Framework to access the state store and publish our state store as a REST API. So I'll be waiting all of you, but before I leave you, remember to like this video, subscribe to the channel, share it with your friends, and leave a comment. The feedback is really useful. Thank you.